I know Reagan's favorite. All right, guys, worksheet 3. So today we're starting section 2.2. Ms. Abruzzo and I just talked about this today. I think we're actually going to break this into 2 separate learning targets because this learning target is on the quiz Friday, but there's an additional part where you need to be able to come up with an equation and do a polynomial regression. So I think we'll just call that a separate learning target. That means if you ace this one and I put it on another one, you still get to keep this 5. Okay? All right. And I hope this will go okay. So we're going to talk about analyzing polynomial functions, but also determining end behavior based on the degree and the leading coefficient. I can determine possible number of zeros and turning points. These should be really easy. But this is an issue for students because some of you still don't know what it means to be an even and odd function. I'm not looking at you. Not looking at anyone in your row. Okay. Someone refresh my mind. Even function. Okay, so this is an even function. This is an even function, okay? And well, but even with a picture, I had some people struggling recently. So we need to be really clear that y-axis symmetry, what does that mean? If I drew it on a piece of paper, yes, you would take it and fold it on the y-axis and both halves would match up, right? Okay, I don't want any confusion about what that means. Okay, odd means what? Origin symmetry, but what does that mean? What does that look like? It looks the same. Whoa, that's not very good. It looks the same upside down as right side up, yes? Even that one has origin symmetry. This crazy business would have origin symmetry. Well, if they were the same length or had arrows. We okay? All right. No, all of this is on there. I can identify the multiplicity of zeros. 2 is on the quiz. So I think what I gave you on the sheet is right. Okay? I think there's just more to it that we're going to make a new one on the next quiz. All right. This is from the fancy factoring. Who's got me on the first one? You don't have these. This is warm up. X squared. X squared. Does that work? X squared times x squared is x to the 4th. Negative 3x squared and negative 1x squared is negative 4x squared. Negative 3 times negative 1 is plus 3. Hannah, I didn't left the room and I forgot to give you stuff. Sorry about that. Does that factor further? This one actually factors x plus 1, x minus 1. This one doesn't factor nicely further, so we could leave it. It would factor x plus the square root of 3 and x minus the square root of 3, but that's kind of disgusting. Okay, what about this guy? Okay, take out an x. Then what? We're going to stab it between this one and this one. There's an x out front still that we can't lose, but what's happening here? Okay, so I'm going to take out a 2x. Then what's left? Ignore that first parenthesis. Okay. I was totally zoning out. Okay, now what? And back here, there's already an x plus 2. So what's in front of this parenthesis? A 1. So we have this quantity x plus 2. I'm just going to take that out and write it down. And left over is an x squared plus 1. And there was out in front an x. That was miserable. Okay, what about this one real quick? Take out an x squared minus 9x plus 20. Which factors? Okay, what about this guy? That's okay. You figured out what wasn't working. We'll get 2x squared minus 4x squared will give you negative 2x squared in the middle. Everybody all right? Anything go further? X plus 2, x minus 2. Okay. We didn't solve any of them. It just said to factor them. Ready? Okay. We're going to talk about graphing polynomial functions. We know the basic characteristics. Yesterday we talked about monomial functions, really weird things like 1/5 x to the negative 3 or 6x to the 4th. They're crazy business. Now we're going to throw on some plus or minus garbage on the back. This definition of how you can write a polynomial is just frightening. Okay, look at all that. It just means, okay, the exponents have to be real numbers, and these have to be real numbers, the coefficients, okay? So 6x to the 5th minus 2x plus 7, that's a polynomial function. We're going to talk about degree. Its degree is the highest exponent, so it's degree 5. Everybody okay? The leading coefficient is the coefficient on the term of highest degree, so the leading coefficient here is a 6. If I write this, what degree is that? No one was tricked, okay? Degree 4, and the leading coefficient is, okay, if we wrote that in standard form, that would be much handier because then it would be out front, but don't be tricked. All right, so things that aren't a polynomial function, just so you know, if you had an x to the square root of 7 power, that's square root of 7 is irrational. Can you have, anyway, I'm moving on. There are things that aren't called polynomials. It does say n has to be non-negative, so you got to have positive exponent powers, okay? You're familiar with the following polynomial functions: the constant, the linear function, the quadratic function. We're all good. So this is degree 1 and this is degree 2. Everybody okay with that? Because the leading coefficient on a quadratic, the exponent power on any quadratic, the highest is a 2. All right. Now we're going to talk about polynomial functions. Polynomial functions, the graph is defined as a continuous curve for all real numbers, and it has smooth rounded turns. Not a polynomial function because it has a gap. Not a polynomial function because it has a hard turn. Okay? Smooth, continuous, defined for all real numbers. So that means it can't have what? No asymptotes either. Okay, those are going to be rational functions, not polynomial functions. All right. Not that I'm going to like ask you to write an essay on the difference between the two. Okay. All right, so all they're saying is if you have an x squared, that's even degree, and if you have an x cubed, that's odd degree, because we're going to talk about the basic shape, yes? This looks like this or this. This looks like this or this. We good? All right, so this is a degree 5 polynomial that has been shifted right to, everybody okay? So it's the same shape as a cubic, but it's been shifted over 2 to the right. What's going on right here? Degree 4 means it's going to be like the negative means upside down. Degree 4 is like a parabola. It could be if there was other terms in there, like a plus 3x squared minus 2x plus 1, then it might have more lumps in it. Because this one just has the fourth power right there, it's just like a parabola upside down. And the plus 1 shifts it up 1. So tell me right here, what shape would this be? Ooh, be careful. Yeah, I'm going to rewrite it like this. So this is the cubic shape. This one's upside down and up 4. So it's doing this, okay? This one, left 7, and it would just look like this. All right. Leading term test uses the power, the degree, and the coefficient to determine the end behavior. And this little box here just says be very careful, because if things aren't written in standard form, you got to watch out, right? We're going to run into one of those in a second here. All right, so this is the leading term test. I have a little chart we're going to fill in on your paper in just a second, but let me just talk through this first. Anytime you have an odd degree with a positive coefficient, odd degree, positive coefficient, this is what the overall shape is going to be. It could also do this in the middle, or it could just do this in the middle, but it's going to be this shape. The ends are doing this, left side down, right side up. Guys, think about this. It's just like a positive x cubed, right? Is that odd degree? Okay. Could be doing some other garbage in the middle, but if you remember that, that'll help cement in your mind. Odd degree, positive coefficient is that shape. All right. Odd degree, negative coefficient. What does that do? Means it's up on the left and down on the right, yes? It could be doing da-da-da-da-da-da-da in the middle. We don't know, but it's up on the left, down on the right. Okay, if it's even degree, like an x squared or an x to the 4th or an x to the 6th, and it's positive leading coefficient, both ends are up. It could be doing this in the middle, but both ends are up, yes? If it's even degree, both ends go the same way. If it's negative, now they both go down. All right, so here's your little chart. An example of an even degree with a positive leading coefficient. X squared, okay? 7x to the 4th minus 2x plus 5. Doesn't matter. There's a couple examples. The end behavior is going to look like what? Yes, both going up. Might look like that, or it might look like this. I don't really know. Doesn't matter. Both ends up. Okay? Y approaches positive infinity on both ends. Whether it's the left, I don't know if I should be taking time to write all this, or the right. Okay. Do you need me to write that, or you get that part of it? Can I just draw the picture? Okay. Even degree, like an x to the 4th or an x to the 6th, but what does this part mean? Negative. So it could have a plain old negative, which would just look like this. Or it could have a negative 2 plus 3x cubed minus 7. I'm just writing garbage because it could be going da-da-da-da-da, a bunch of loop-de-loops in the middle. But either way, both ends are going to go down. Anytime it's an even degree, both ends go the same way, the leading coefficient tells you up or down. Everybody seem okay with that? Just remember a parabola. Most basic even degree. All right. Odd degree. Give me an example. Okay. And a positive leading coefficient. So it could be 4x to the 5th minus 3x to the 4th plus 2. Who knows? As long as the leading coefficient is positive and the biggest exponent power is an odd number, what's the shape going to look like? Odd means the ends are going opposite directions. So which end's down here? Left end is down, okay? There's your cubic shape, or it could be doing a bunch of gobbledygook in the middle, but the left end is down. Negative infinity on the left, infinity on the right. Can you remember the cubic shape? If you just remember the cubic, represents all the odd functions of positive leading coefficient, then you're good. And the last one, what happens to all these x to the fifth or x to the third plus 2x minus 4? What's going on? I'm supposed to have what kind of a leading coefficient though? A negative. So I could put a negative out here. I could put a negative 1/3 just to make life difficult. Bottom line is what's going to happen. Left end is up. Okay, it might be doing something in here. Oops, that shouldn't be a sharp turn. Just kidding. Okay, or it could just be a basic thing like this. But the left end is up and the right end is down. Any questions? Are we comfortable with all that? Okay, what's the difference then, one more time, between an even and odd degree and an even and odd function? Even degree has to do with end behavior, yes? Same way, right? Both ends, same way. Whereas odd degree is still end behavior, but the ends go opposite ways. Okay, so it might look like this or like this. One end's up and one end's down, whichever end. Even and odd function, totally different. Tell me one more time. Y-axis symmetry. That's a horrible picture. And this is origin symmetry. Vocabulary is so important in this particular part of things, okay? Everybody okay? All right, so this is a big complicated question. It says, describe the end behavior of the graph of the polynomial function, explain. All you need to look at is find that highest degree. You can ignore the rest. So this is a degree 4, which is even. It has a leading coefficient of 2, which is positive. So it should be both ends up, yes? I don't care what it's doing in the middle. I don't even think this is a good graph for this picture. Doesn't matter. Both ends are up, okay? So let's decide this one. I don't know if you have this one. Do you have this one? Okay, just look up here. Tell me what you think. What's the degree? Leading coefficient? Positive 3. So it should be both ends up. Whatever it's doing in the middle doesn't matter. Both ends are up. Which would write how? Both ends. We would write it this way, right? Approaches infinity as x approaches negative infinity, approaches infinity, oh my goodness, as x approaches positive infinity. That was a hot mess. We good? All right. What about this one? Oh, you guys are so good. Look at there. It's in the middle. So it's degree 7 with a negative leading coefficient. What does that mean? The left end is up. Okay, think of a cubic that's been flipped over this way. Might have a whole bunch of garbage going on in the middle, but that's the shape. Okay, so this is the graph they give, which is a mess, but the left end is up. Okay, as x approaches negative infinity, it's up. As x approaches positive infinity, y is going down. Okay, now I wrote it backwards of what we usually do, but we're good? All right, then we need to talk about something called extremo. Turning points. Every time there's a max or a min, the graph turns and goes the other direction. That's what makes it a relative max or min, right? So those extrema are also called turning points. In other words, it turns and goes the other direction at a max or a min. When you have, what degree might this one be, guys? Degree 3 would be a good guess. Could be 5 or 7, but degree 3. Okay, how many turning points does it have? 2. This is degree, how many times might this cross? 1, 2, 3, 4, 5. So it could be degree 5 because it could have 5 zeros. Do you see what I'm talking about? If this was my x-axis randomly thrown in there. How many turning points? 2, 3, 4. What about this guy? Both ends are the same. It could possibly have as many as 4 zeros. It has to be even, right? But it could have as many as 4 zeros. So if this was degree 4, it'd have a negative leading coefficient. Goes down, but how many turning points? How many maxes and mins? 1, 2, 3. Anybody seeing a pattern? Yeah. The degree equals the number of zeros, and if you subtract 1, you get the number of turning points. If you subtracted another one, you'd get the number of possible inflection points. Remember, between every max and min, there was an inflection point? We don't want to talk about inflection points. Just okay. So the degree tells you the maximum possible number of zeros. The degree minus 1 is the maximum number of turning points. It doesn't mean every graph will have that many turning points. Guys, if I have a plain old cubic, that's degree 3. Does it have turning points? No. But could a degree 3 possibly have some turning points? Yes. It's the maximum possible number. It doesn't always mean that it will have that many. For example, real quick, can you have a parabola that has no zeros? Absolutely. It has imaginary roots, right? It would look like this. That's degree 2. It still has 1 turning point, yes, but it has no zeros. So this n and n minus 1 thing is telling us the maximum possible. Doesn't mean it's going to have that many. All right, on the back, I think, of your worksheet, it talks about the vocabulary. When you have a polynomial function and c is an x-intercept, it is equivalent to say, all right, so if I wrote y equals x minus a, x minus b, x minus c, you would all say that c is a 0. If this was in factored form, would that make sense? Set it equal to 0, c is a 0. X equals c is a solution. So if I had this, you would tell me 4 is a 0. Whoa, I don't know what that says. 4 is 0. 4 is a 0. X equals 4 is a solution. We good? Just trying to. And x minus 4 is a factor. Those are very similar, yes? That vocabulary? Okay, kind of all talking about the same thing. All right, you can find the zeros of some polynomial functions using the same factoring techniques. Oh, we've been warming up on this for a week. All right, so here's one. X cubed plus 2x squared minus x minus 2. What degree is it? So the maximum number of turning points. So zeros could be as many as 3. Turning points could be as many as 2. Can we factor it and find them, the zeros? This one you could take out an x squared out of the first 2. What would you take out of the other 2 back here? A negative or a negative 1. Is that okay if I write it that way? And then x plus 2 and x squared minus 1, which still factors x minus 1 and x plus 1. Okay, so Did we find the zeros? It says, say the number of possible real zeros, 3. Turning points, 2. Determine all the real zeros by factoring. The zeros are at -2, 1, and -1. Okay, here we go. How many possible real zeros? Because it's degree 4, this is 4. Number of possible turning points, maximum number of possible turning points is 3. How would we factor this? Might take some of you a little while, but yeah, it's not plus 3. To get a positive 18, I need 2 negatives so that I get a negative in the middle. Foil it back together if you need to. Does it work? Okay. Does that factor further? No. Can you find me the real zeros, though? X squared minus 6 equals 0. X squared minus 3 equals 0, which means x squared equals 6. So x equals plus or minus. You don't have to show all that work. I just want to show it once so you're okay with where we're getting it. X squared equals 3. X equals plus or minus square root of 3. Are those real zeros? Are they real zeros? What's non-real? Okay, i's, right? Do these have any i's in them? They're nice, disgusting decimals. Does anybody remember what that's called? They're real. They're just not rational. They're crazy. Okay? They're not rational. So these are real zeros. They're just not rational. You don't have to find any with i's today. We'll save that fun for another day. Okay. What about this one? Okay, let's start by degree 5. So it has 5 possible zeros. How many turning points? 4. Factor, take out an x, I heard. X to the 4th minus 6x squared minus 16. Now what? X squared and x squared minus 8 and plus 2, she said. Does that give us a minus 16 at the back? And the inside outside give us a negative 6x squared in the middle? Okay, be very careful. What does this mean? There's a 0 at 0, right? Now, if I took out a 2, would there be a 0 at 2? 2 can't equal 0, right? But x can equal 0, so I just throw that away. Just kidding. It wasn't really there. So we get a 0 at 0. If I set this one, what do I get? Yeah, x squared equals 8. X equals plus or minus the square root of 8, which is 4 times 2, which is 2 square roots of 2. Okay, made me want to cry a little bit. What about this guy back here? X squared plus 2 equals 0. X squared equals negative 2. X equals, Yep, fake news. Non-real 0, we don't have to find it. It's plus or minus I square roots of 2, but we don't have to find it. We're done. We okay? All right. I don't want to graph this really. I just want you to think about the end behavior. I don't want to take time to find a nice window and all that garbage. What's the degree here? 5. Degree 5, leading coefficient, negative. Okay, degree 5 normally looks like this, right? Like a cubic, but this one is what? That didn't work as well as I thought it would. Okay, flipped everything upside down. Okay, because of the negative leading coefficient, it's going this way. So I don't know what it's looking like, but it's going this way. So describe the end behavior to me. F of x approaches, how do I write the rest of that? Okay, on the left, it's going up. F of x approaches negative infinity as we go to the right. Can you put your phone away? All right. I'm going to skip this question. I think you have it on your worksheet. I'm skipping it. We're going on. Multiplicity of a zero. Does anybody remember this fun, that if you have an equation like this, that it crosses at 0, but at 2 and at 4, because it's a squared, it actually bounces off the x-axis, not crosses? Anybody remember that? Okay. I like to call it a bounce. It bounces off the x-axis. Some teachers will say it's either kiss or cross. It either just barely kisses the x-axis or it totally crosses. I usually say cross or bounce, okay? We don't want any sexual connotations, right? Okay. So this is, what degree would this be? I don't know why this bothers students so much. If you FOIL this out, it would be a degree what? It'd have an x squared, yes? This would have an x squared, and this is an x. So if I multiplied that all together, I'd get x to the 5th, okay? I know there'd be a whole bunch of other garbage, but all I care about is that, the highest power. Okay. If it's degree 5 with a positive leading coefficient, the left end is down. Okay, the zeros were at 0, what, and what? 2 and 4. Okay, what is it? So it's coming from here. Is it cross or bounce at 0? Why? It's only a multiplicity 1. That's a new vocabulary possibly, but multiplicity means what degree is the 0? Is it repeated? So it crosses. But when we get to this one, it's a degree 2 or a multiplicity even crosses. Multiplicity even crosses. Bounces again. Did I just say crosses? It bounces at both of those. I'm sorry. If this had been a degree 3, well, first it'll change everything. We're just going to go on. Okay. So what do we got here? If 0 is an odd multiplicity, so it's a multiplicity 1 or 3 or 5, then it crosses. If it's an even multiplicity, they say it is tangent to, or just barely touches the axis. All right, so here we go. I love these questions. Okay, I'm going to draw a really bad graph. Wow. Okay, where are the zeros at? Can you give me 0 values? This -2 is not a 0, right? So 0, 0, 4, 0. If you could just, you don't have to write them as ordered pair. What's this mess right here? 1/3. Okay, 0, 1/3, which I'm moving way over here, and 4 I'll put way over here because I want to spread them out enough I can graph this. Okay. Now, apply the leading term test. That means ignore everything but the leading term and figure out what's going on here. So I have a -2x and I have an x. I'm not going to worry about the -4. And back here I have a 3x cubed. So what's the highest degree going to be? If we just worry about the x's, we'd have x to the 3rd times an x times an x is an x to the 5th. I really don't care what the leading coefficient is. 3 to the 3rd is actually what? 27 times -2 is -54. All I really care about is that it's what? Negative. So you could have even not worried about this 3 as long as, and this 2, as long as you remembered it was negative, okay? So we have a negative, so what shape should that be? Let's see, a cubic is that way, but a negative, we got to flip it over, right? So it's going to come from the top. Okay. Oh, we need to write multiplicities. Okay. So I'm going to write 0 is a 0 at multiplicity what? You don't have to even write it. It's multiplicity 1, yes? It doesn't have any squares. Okay. 4 is a 0 of multiplicity. Oh, I can't write that word, apparently. 1. But 1/3 is what? You have to identify that as multiplicity 3. 1/3 is 1/3 of multiplicity 1. 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 1/3 is 1 The other two, you could have just written 0 and 4. But this one, you have to tell me is multiplicity 3 when it says state the multiplicity of any repeated zeros. Okay, if it starts from up here, what's it going to do at 0? Cross. Why? Odd multiplicity. Very good vocabulary. 1/3. It's going to cross again because it's odd multiplicity, right? What it actually probably does is makes a little baby cubic shape. So it kind of does this there. But I don't care. You're fine with just making it cross. It's because it's multiplicity 3. It actually looks like a little baby cubic right there. Okay? Then what happens at 4? Cross again because it's multiplicity 1. Do we have the correct end behavior that we wanted? Okay. Now, part C says find a few additional points to graph this graph. Guess what, guys? Old school, no graphing calculator. Hofbauer had to try things in here to see just how high this went up and just how low this went down. You don't have to do that, okay? Just don't put any scale on your y-axis, and this is a good picture. I'm fine with that. Let's try B. Uh-oh, this one is easier in some ways, yes? The degree and leading coefficient are easier to find. What degree is it? Degree 3, leading coefficient, -1, so it should be the same shape as the last one, right? Okay, but what do we need to do now to find the actual zeros? What do you want to take out? I think a -x would make me really happy too, because then we'd have x squared minus 2x minus 8. Did I do that right? Which will factor further how? X minus 4 and x plus 2. Everybody okay? All right. So what are they asking us for? The zeros are where? 0, -2, and +4. All multiplicity 1, yes? Which means you don't really have to list the multiplicity. All right. End behavior, we already described it as this. So what's going to happen? At 0 and at -2 and at +4. I'm going to cross at all those. And I know the left end should be up, so it's just going to do this. And I don't really know. It could go super high or not. Yeah, we're using the Hofbauer big dot theorem again. Okay. One more for fun? Sure. Because neither of these had bounces, did they? We should see if there's a bounce. Is there a bounce on this one? Okay. I want to play with this leading coefficient thing again, guys. It's a -x. This is going to be a 2x squared if we ignore the rest. And this one's just got an x. I really don't even care about the 2. What would happen? I'd get an x to the 4th when I multiplied them all out, right? And the leading coefficient is negative. It's actually like a -4, but I don't care. All I want to know is that it's negative. All right, so what shape should that be? Draw a little sketch before we even start. It should be upside down something. There we go. All right, now tell me about the zeros. 0, -5/2, and 3. Everybody okay? Where those came from? This one is multiplicity 1, this one is multiplicity 2, and this one is multiplicity 1. Who doesn't have any idea what I'm talking about? Everybody in here gets the multiplicity thing? Here, 2x plus 5 equals 0 is where I got the -5/2, okay? The multiplicity means this exponent here. So if this had a 4 on it, this would be multiplicity 4. Is that better? Yeah. Okay. Da-da, da-da, da-da. How far back do I want to go? Okay. I think we're ready to go, aren't we? If I put a negative 5/2, a 0, and a positive 3 on my graph paper, where am I going to come from? On the left, it's going top or bottom? It's coming from the bottom. What does it do at this, though? Because of the even multiplicity, it's going to bounce off and not cross there. And then what's it going to do at 0? It's going to cross, and then it's going to cross again. Does it give us the proper end behavior? Clearly, it has a 0 at 0. All right. That's the huge dot there, the Hofbauer huge dot. All right. This is your assignment tonight, guys. Yeah. 3, 8, 15, 21, 23, 25, 33, 37, 41. So there are 9 questions.